Okay, so let's start the lecture. Okay. Okay, guys, so let's start. So last time I told you we have three main gates. They are the basic gates. We are going to create everything from these gates. The first one is called inverter. We call it inverter, or we call it like not gate, as you see here. This is the picture. This is the symbol of this gate, as you see here. And I told you this is how it works. If the input is 0, we get 1. If the input is 1, get 0. That's why it's called inverter. You can tell from the English name. Is that okay? I told you something before. Okay. In this course, I'm not going to teach electronics. Okay, but you should understand we are going to focus on the logic circuits or logic symbols like this one. But you should understand there is an electronic circuit that can be used to implement this function. Okay, and usually we use transistors. Okay, I'm sure most of you still don't know what I mean by transistor. So I'm gonna explain something right now, but if you don't understand it, that's okay. Just I wanna give you some idea how the electronics can do something like that. Okay, so for example, you can implement this one using transistor this way. You have a transistor this way here. Here we have ground here, and then we have here like 5 volt, something like that. And this is the input, and this is the output is here. So actually what happens is that if the input is 0 volt, logic 0 or 0 volt, if the input is 0 volt, so the transistor is off. I told you the transistor is like a switch. So the transistor actually, it should be like a connected, like a switch. We have a switch here. So this switch can be short circuit, or it can be, if it is open, it becomes what we call open circuit, right? This is short circuit. So connect or disconnect. Here, because the input is 0 volt, the transistor is off. Because the transistor is off, there is no current this way. And because of that, so actually this circuit looks like you have here and then off. It's like open circuit, this one. That's why when you take the voltage here, you find the voltage is 5 volt, and this one is 5 volt. So when the input was 0 volt, the transistor, the switch is off, and then I got 5 volts. Is that okay? Again, just I want to give you some idea how can we do these crazy things, but just an idea, right? Okay, so I'm not asking you to examine anything. Let's see the other case. When you input here 5 volt, okay, so now the transistor is on. On here means a short circuit. So now the transistor you connect, it's like a switch, as I told you. You connect it, becomes like a short circuit. And because this is a short circuit, the current is gonna go this way, and we're gonna get here 0 volt. Is that okay, guys? So you can see every time I put 5 volt, I get 0. When I put 0 volt, I got 5 volt. Just to give you some ideas how it works. Okay, we have some electronics behind it. Okay, then I told you last time there are 2 very important things. We are going to use them all the time. Something we call truth table. This truth table has all possible inputs and all possible outputs. Here, because I have only one input, this input has only 2 cases, either 0 or 1. Okay. Also, we have something we call timing diagram. The timing diagram here, as I told you, this is the time. This is the time, and this is, you can say this is like a voltage, or this is the logic. Okay, so here this is logic 0 here, and then for some time here logic 1, for some time logic 1, for some time logic 0, for some time logic 0, and so on. So when the input is logic 0, here I got logic 1. When the input is 1, I got 0. When it is 1, I got 0. When it is 0, I got 1. When it is 0, got 1. Okay. So also we use also. So I want you to be familiar, or we're going to use it all the time. Something like timing diagram, okay, and also truth tables. Okay. Also, last time I explained very important gate. We call it AND gate. And the very easy way to explain it is, this is the truth table of it. Again, here, because we have two inputs, how many possible cases we have here in the truth table? Okay, 2 to the power of 2, right? And you have two input, so all possible cases 2 to the power of 2. That's why we have here two input. We should have how many cases here? 4 cases. Okay. Also, you don't need to memorize anything. I told you there is a pattern. You can generate these cases. How can you do it? For the first one here can be 0, 1, 0, 1. For the second one, 2 zeros and two ones. That's it. Okay. And then this is the output. So if the truth table has all possible cases here. The two input can be 0, 1 input 0, 1 input 1, 1 input 1, 1 input 0. The two inputs are 1. So all possible cases. Was that okay? So here, the way I can explain how this one works is, number one, the only way to get 1 here is when all inputs are 1. That's it. Any other case is 0. The only way to get 1 when all inputs are 1. I can say it in another way. I can say also, it's the same thing. I can explain it in a different way. I can say, if one input is 0, the output is 0. Don't think about it. It's enough to have one input 0, okay, to make 0. Okay? That's why you can see the truth table is this way. Okay? Here, it's enough. You have 0 here. I don't even need to look at these ones. You have zeros. Okay, I'm going to get zeros here. Okay. Now I have here 1. So this time I'm going to look at this one. This one is 0. I'm going to get 0. The only way to get 1 when both of them are 1s. Is that okay? And again, this is similar to what we do in our life. When I tell you, you have to do lab 1 or lab 0 and lab 1. So you have, that means in order to get, that means in order to satisfy the condition, you have to do both of them. If any one of them is missing, you don't satisfy the condition. Okay. So next one here for OR, we have another. This is the symbol for AND, and this is the symbol for OR. Okay. Oops, this is the old one. Okay. Anyway, I told you I corrected this one. I just repeated the end, so I corrected it on the course website. I sent you an email about it. But before I leave this one, here I give you one example here. When we have two inputs, okay, we can have another gate, another AND gate with 3 inputs, 4 inputs, 5 inputs. Okay, you can design it this way. For example, here I give you just an example. Here we have AND gate, but we have here 3 inputs. Okay, because we have 3 inputs. How many possible cases we can have? 2 to the power of 3, which are 8. So you can see here we have 8 cases here. Okay. How can you generate them? Very simple. The pattern I told you about. So 0, 1, 0, 1, 0, 1. Okay, 8 times. And then here, 2 zeros, 2 ones, 2 zeros, 2 ones. And then 4 zeros, 4 ones. That's it. Okay. If it is 5 bits, 6 bits, if it is 1 billion bits, it's the same idea. You can use the same pattern to generate all possible. Is that okay? Anyway, but how this one will work? Okay. Okay, very simple. Similar to what I explained before. The only way to get 1 here when all inputs are 1s. That's it. Any other case, you are going to get 0. That's why you can see here, it's always we got zeros because it's enough to find 1 0. It's enough. Once you find 1 0, okay? If you find 1 0, it's enough to get 0, okay? The only way to get 1 when all inputs are 1s. Any questions? Next one here. Or again, think about it. When I tell you, you should do lab 1 or lab 0 or. So or means one of them should be enough. If you want to do both of them, that's okay. So any one of them, it should be enough. Okay. In other words, here for OR gate, in order, the only way I get 0 here when both of them are 0. The only way you didn't satisfy my condition is if you did not submit lab 0, and also you did not submit lab 1. It's 0 and 0. Okay. I can say it's the same thing in a different way. I can say if one input is 1, okay, it's enough. Don't look at the other one. I am just looking for, it's enough to have 1. So if one input is 1, the output is 1. Don't look at the other ones. Is that okay? So let's do the truth table. Let's correct this because this is for AND. So here, The only way to get a 0 when the two inputs are zeros. So this is correct. Okay. Now, if you have only one input is 1, I'm going to get 1. It's enough to have one input. Here, 1. So 1. 1 and 1, I'm going to get 1 here. So it should be 0, 1, 1, 1. Okay. Please correct it. And also, I already corrected it and uploaded the new slide, but this is the old one. Okay. Any questions? Same thing again. We can have 3 input OR gate. We can have 3 input OR gate as you see here. 3 inputs, so we're going to have 8 cases, 8 different cases. Also, the same idea. The only case I'm going to get 0 when that all inputs are zeros. If there is only at least 1, at least, if we have more than 1, okay, it's more than what I need. If you have only 1 here, the output is 1. Any question? Very easy, right? Any question? Good. Now I told you these are the basic gates. Okay, using these basic gates, I'm gonna make circuits. I can make a circuit to do addition, to do multiplication, to do anything, as you will see in this course, using these basic gates. Is that okay? So that's why here I want to explain to you what we call Boolean function. Okay, as you will see right now, I'm gonna use the basic operation I explained right now to create functions. For example, let's have this example here. Okay, so here this is a circuit. This circuit, how many inputs this circuit has? This circuit has 3 inputs, A, B, C. So it has 3 inputs, A, B, C. And then what this circuit actually is doing, as you see here, let's read this one. Okay, so it's gonna do AND. I told you before, when I say A dot B, dot here means AND. Sometimes we remove the dot. Okay, so sometimes we say AB. Okay, so here let's explain to me what this one here is. Okay, I'm gonna explain to you. Look here. We have this is an operation, AND operation. Okay, so in this AND operation, I'm gonna AND with me. Okay, we are gonna AND A, as you see here, A and the complement of B. Okay, that's why if you look at the circuit here, we have AND. So this AND actually is here. This AND here is here. This is this AND. So this AND has A and also has B and then complement to B here. So if I input here B, I'm gonna get complement to B here. And because the input here is A and complement to B, so I'm gonna get AB prime. AB prime is actually the first term here. Okay. And now we're gonna have OR, as you see here, we have OR operation here, and this OR operation should do OR, logic OR between this one and C. So that's why I'm gonna get this one at the out. I'm gonna give you more example to understand. So what I wanna see here is using the basic 3 operations I explained, and or not, we're gonna create functions. These functions, okay, or sometimes we call it logic expression or function or circuit. Okay, so we're gonna do a combination of them to do something more complicated, or we're gonna do like operation you will understand. Okay, this is just for teaching. This function are not doing anything, but in the future you will see, or not in the very far future. I think in lab in lab 2. In lab 2 you have one function. Okay, I'm just asking you about the simulation, but this function is for the majority. Okay, so you will see something like this one here, and the output here, the output will give you 0 or 1. If the majority is 0, give you 0. Majority is 1, give you 1. Okay, so anyway, so in the future we are going to create some functions using these basic gates in order to make addition, subtraction, multiplication, whatever you will see later in this course. Okay, so all what I need from you right now is to understand, number 1, what I mean by Boolean function. Boolean function, it's similar to the functions you learned before. This function has inputs, but be careful. All variables or inputs here are binary, 0 or 1. Okay, so A is 1 bit binary, can be 0 or 1. Okay, B, C, all variables here. Okay, same thing for the output of the function. The output of the function here also binary, 0 or 1. Is that okay? So here I'm gonna take inputs A, B, C, and then I'm gonna do some operation here, and then I'm gonna get the output here F. Okay, so what kind of operation you did here? What I did is I complemented B I do AND with A, and then I calculate it OR with C. Okay, let's have the next one here. So all what I need from here, guys, three things. Listen to me, please. I need three things from you here. Number one, understand what I mean by Boolean function, or I'm gonna say a logic expression. Okay, it's the same thing. You understand what is this? Okay, so you can see I'm gonna use a combination of the operation I explained, so that you are gonna get an output here. Okay, this output again 0 or 1. Number two, you should understand if I give you this function this way, you should be able to draw it this way. Okay, or the opposite. If I give you this one, you should be able to get this one. Okay, as you will see right now. For example, let's look at the next one here. Let's start, for example, yeah, if I give you this one and then I ask you to write the function, how can you do it? Very, very simple. Look at here. Again, how many inputs we have here? We have A, B. Remember, A and A prime. A prime is not a new input. A is an input. A prime is an operation, it's a complement of A, right? So here's the inputs we have. We have A, B, C, D, E, right? A, B, C, D, E. We have 5 inputs here. Okay? So how can you calculate the last function? Very simple. Look here what I did. This is C, D, and this is OR operation. So I'm going to get here C or D. And this is also 1 bit, 0 or 1. Okay? And then here, this is AND. So this is A, and whatever I have here. So A and this one. Is that okay? Again, all of this just 0 or 1. Okay? This one's the value of A, C, and D. Right? Also, here, this inverter is going to complement this one. That's why look here, I put a prime here. That means whatever I have here, complement it. Okay. And then here, this is AND. So we have B and E. B and E. Okay. And then I'm going to do OR here, OR between these two. And this is the output I'm going to get. Okay. So again, if I give you a circuit like this one, it's very easy to get the function. It's the same thing. The opposite. If I give you a function, you should be able to draw the circuit. Okay. For example, here in this case, you can see here. How can you do it? I'm going to show you. Look here. I'm going to do the opposite now. Okay. Given this function, how can you draw this one? Look here. Very simple. First of all, I have one term here, and I have one term, and we have OR. So I can do this one here. Okay. We have OR and this term and this term. Okay. Then let's do this term first. Okay. So that's why this is B and A. So I'm gonna do B and A. And now I finish this term. Okay. Let's come to this term. Okay. So here we have here inverter. So in order to calculate this value here, okay. So I need to get this one here. Okay, using inverter. Okay. And in order to get this one, so here one input should be C or D, and the other one is A. So A is okay, it's done. I don't need to do anything about it. But here there is an operation here. This operation is OR, so I have to do this one. Anyway, again, I give you a lot of examples in the slides, but what I'm expecting from you right now, you should understand what I mean by function. Okay, function means we have some very similar to any function, but instead of using multiplication and division as used, and addition or subtraction as used before, it's exactly the same thing you did before, but I'm going to use AND or complement. Is that okay? So one more thing, as I told you, one of the things we are going to do all the time. So this is a function. This is a function. I want to know how this function works. Okay. For example, so you can tell what this function is doing. It's just doing OR between input B and complement of A. So as you see here, we have A, complement of A, and then I OR them. Again, this is one. Every variable here is 1 bit. So this is 1 bit 0 or 1, 1 bit 0 1, 1 bit 0 1, 1 bit 0 1. Is that okay? Now, very important. We are going to use. If you want to know what this function is doing, okay, truth table can help you to do that, or the truth table can tell you how it works. Okay, so how can you create a truth table for this one? Okay, so what happens here? Let's do it. For example, here, number one, what? Okay, I'm gonna hide. Let me hide these ones for now. Okay, so look here. As I told you before, number one, this is the input. The input here. How many inputs you have? You have two inputs, A and B. Okay. How many possible cases you have? 2 to the power of 2. So have 4 cases. 1, 2, 3, 4. How can you come up with these 4 cases? I told you many times. Just the first one here, flip 0101 and then 2 zeros to 1. So these are all possible cases for this circuit or this function. Okay. This function cannot have any other values. This is all the possible cases. We have 4. Now, in order to calculate this one, so I need to calculate A prime. Okay, so that's why I'm gonna make one column here for A prime. Okay, once I calculate A prime, so now I'm gonna do here OR between these two. I'm gonna do OR. So let's start with the first one. I'm gonna take A, and then after I'm gonna do prime to get A prime. Okay, how can you do that? Very simple. Are you 0? Yes, so you should be 1. 0, 1. Inverter, right? 1 here should be 0. 1 here should be 0, right? So here you can see, if you look at this column and you look at this column, okay, in every value is inverted. Okay, but this is A prime of this one. Is that okay? Now let's do F. I want to get the value of F here. F is actually, so now I'm gonna take, I need to make OR, okay, or between B and A prime. So here I only want to look at this column and this column. So I just want to look at these two. Okay, I want to make OR between them. I told you in case of OR, just I want to make it very quick, very quick. The only way to get a 0 when the two inputs are 0. Okay, if look here, guys, 1 and 1. I don't even need to look at these ones. Okay, 1 and 1 has to be 1 and 1. I'm teaching how to make it quickly. Okay, so once you find the 1, okay, it's 1. So this is the output of this function. Any question? So this is the output of this function. Any questions? So what I'm expecting for you now, if I give you a function, you can create a truth table like this one. Is that okay? Later, I'm going to explain how can you do the opposite. And the opposite is complicated. Okay? What do you mean by the opposite? The opposite is I can give you a truth table, and then you can give me the function. Okay? And by the way, this is how can you design something? Okay, what do you mean? I'm gonna tell you what I'm very simple. I want to do multiplier. I want to do multiplication. Okay, so 0 times 0 is 0. Just write here whatever you want at the output. Same thing here. 1 and 0. How's the output? It's up to you. You can write here whatever you want. Okay, based on what you want to do, and you should see this in this lab. So in this lab, you have a majority, the majority circle, very small circle. Okay? So you can see here the majority is 0. Okay, so when I have this input, you have to give me 0 here. I put 0. Okay. Here the majority, there is no majority here, so I'm gonna consider it like if there's no majority, I'm gonna consider it. If the majority is 1, so I'm gonna put 1. Whatever you do. Okay. Here maybe the 3 input, I would not have a time. Anyway, so what I'm explaining here later in this course, again, 2 things. I don't want to confuse you. There are 2 things now I'm explaining. Number 1, if you have a function, how can you create a truth table? This is number 1. That's what I explained. Okay? And that's easy. Just to put all possible cases and then try to get what is the output here. So this is the input, I'm going to get this one. Get the input, this input, get this one. Later in this course, we're going to do the opposite. Okay, I want to do addition, subtraction, whatever. So what you have to start with the truth table. Okay, when this is the input, I want the output to be this value to do multiplication or to do addition, whatever. Once you create the truth table, you have to go back and get the function. Okay, that's what I'm going to explain later. Okay. So here I just give you 2 examples here. Again, as I told you, if you have a drawing like this one, I'm expecting you should be able to get the function. For example, here, as you see, this is y and this is inverter, so this should be y inverted. Okay, this is x, so this is x. Here, this one is coming from here, so this is x prime. So this input should be x prime. This is y. So what I have to get here is actually x. That's wrong, right? So this is x prime. No, I think this one is, I'm sorry, I'm gonna correct it, okay? So this one actually is x, you can see here x, right? X y prime. Okay, and this one is coming. This one here is coming from x prime and y. So here x prime and y. Is that okay? This one is okay. But yeah, I just switched it. So here the input here is x, the input is y prime, and x prime, x prime and y, and then x prime y, and then 4. So this one is okay. So now also you should learn how can you do the opposite as well. Okay, I don't want to spend more time on this, but for example here, given this one, if I give you this one, you should draw it this way. Okay, so as you see here. Any questions? Just if you want to learn more, I give you more examples here. Okay, I give you more examples. How can you, if you have this one, how can you draw it? Or in the opposite? Okay, so you can think about how can you do in the opposite way. Any questions? Okay, now in this section, I'm going to talk about basic theorems. Okay, what do you mean by basic theorem? I'm going to tell you. Look here, guys. Now I'm going to explain Boolean algebra. Okay, similar to what you did in the normal algebra. Okay, what we are saying normal and Boolean. What do you mean? It's not different. In normal algebra, what operation we have? We have addition, subtraction, we have multiplication, we have division. Now we don't have these ones, right? What we have here is inverter, not. We have or, we have and. Is that okay? Here, so this is the main difference. So if you have some variables and you have this operation, how can you do algebra? That's what I'm going to explain. This is the main difference. You will find some similarity between the normal algebra and the Boolean algebra. You will see some similarities, but also there are some differences, as you will see right now. Is that okay? For example, one of the similarities you will see right now. So if I have 3 multiplied by x plus 2, you remember the distribution you used to do before? Yes, this one should be 3x plus 6. Okay, because we do multiplication. We are going to do exactly the same thing here, okay, but using logic. For example, if you have here a, for sure, again, here we don't have 2, 3, 4, 5, 6. Please, everything here is binary. So everything here is just 0 and 1. Cannot be anything else in Boolean algebra. So if we have here A and B or C. So here it's not multiplication, it's and. This is not addition, it's or. So here also I'm going to teach, as I'm going to teach right now, also we can do distribution like this one. So this one will be similar to A and B or A and C. So you will see right now. Anyway, so let's start. So we have here several theorems I'm going to explain. At the very end, I have one slide here. I summarize everything here in one slide. And I'm okay in exams or anything else. I can give you this slide, okay? So I don't want you to memorize anything, but still, you need to know how can you use them as you will see in this course. Anyway, so let's start with the first one here, okay? Again, A is a Boolean variable. It can be 0, it can be 1, okay? A or 0, what is the result? Should be, okay, let's start with the easy one. Okay, for example, A and 0, what is the result? The result always 0, regardless what is A. Is that okay? Because this is how and works. If one input is 0, I'm going to get 0, regardless of A. Okay, now A or 1, I'm going to get 1, regardless what is the value of A. And also to convince you, for every one of them, I created a truth table just to convince you. So here, A can have 2 values, either 0 or 1. Okay, 0 or 1, I'm going to get 1. 1 or 1, I'm going to get 1. Is that okay? So always the result of is 1, regardless of what is the value of A. Okay, makes sense. This is how OR works. Okay, let's look at this one here, A or 0. Okay, so now if you have one input is 0 and one input is A, so actually the output here will be similar to A. Can you convince me? I'm going to convince you. Look here. For example, if A is 0, I'm going to get 0, right? If A is 1, I'm going to get 1. So, okay, so here I give you like a truth table here to convince you. So here, if one input is 0 and A is 0, I'm going to get a 0. If A is 1, I'm going to get 1. Is that okay? So this is, so A A or 0, I'm gonna get A. Okay. If you wanna if you wanna make similarity with the normal algebra, x plus 0 is x, right? But I don't want to confuse you. Here we don't do addition, we do logic OR. Okay. So this is here. Another one here. Same thing for n. For n, if one input is 1 and this one is A, okay, and this A can be 0 or 1, as I told you, the output will be similar to A. So if A is 0, I'm gonna get 0. If A is 1, I'm gonna get 1. Any questions? You need to understand this theorem very well, because we are gonna use them as you will see. Okay. Now I'm gonna talk about another expression we have here. A or A prime has to be 1. What is the logic behind it? What is the logic? Okay, I don't want to just give you and look at the truth table, it works. I also want to give you the logic. What is the logic? A and A prime should be 1. Simple. The logic is, in case of OR, I'm looking for 1. If I can get 1, the output is 1. Okay. And because I have here a bit and I have the inversion of this bit, so I guarantee I'm gonna have 1. Because if this one is 0, the other one will be 1. If this one is 1, the other one will be 0. Because I'm saying, so in case of OR, I'm just looking for 1. And because here you have A or A prime, okay, I am sure one of them should be 1. I am sure, right? So that's why I'm going to get 1. Okay. Same thing here, A and A prime. For sure, I'm going to get 0. Simply because in case of N, the only case I can get 1 when the two inputs are 1s. And in this case, it's impossible that the two inputs are 1s. It's impossible. Because I have a bit and the inverted value. Any questions here? Okay. Let's look at this one. This is also very logical. If you calculate A, and then you get, so if you have here A, I'm gonna get the complement of A here, okay? If you complement the complement, you are gonna get A back. Makes sense, right? It's true. So here, complement of the complement is A, right? Because simply you can look at the truth table again here. If I have 0 here, 0 becomes 1, and this 1 returns 0 again. Okay? Any questions? Okay. The next one here. Okay, guys. Two important things here. Number one, you have to understand these rules very well. Okay. It's like it's like the normal algebra. If you have a function and you want to simplify it, if you want to add two functions together, in this case, you apply the rules. You learn it in algebra. Okay, it's the same thing here. Okay. So two things. Number one, you should understand these ones. Number two, as I'm going to teach you later, how can you use them? How you will use them? I'm going to tell you how. But let's finish them first. Now I have also here what I'm saying here. One of the rules we have here is, if you have or A, I'm gonna get A. What is the logic? I'm gonna tell you what is the logic. The two values are the same, A and A, right? So this one has only two cases, 0, 0 or 1, 1, right? So in case 0, 0, I'm gonna get 0, right? 1, 1, I'm gonna get 1. So it's the same. What I'm saying. And you have the two. Same thing here for AND. If you do here A and you put A, I'm gonna get A. Again, I have only two cases, either 0, 0 or 1, 1. This is the only two cases I have, right? So in case of 0, 0, I'm gonna get 0. So it's similar to A, right? If the two input are 1, 1, I'm gonna get here 1. It's similar to A. Any questions? Okay. Now, I want to talk about, this is something similar, commutative. This is similar to algebra, normal algebra. Okay, for example, when you say 3 plus 2, it's the same if I say 2 plus 3, right? This is the normal algebra. Okay, it's applicable here as well, but we don't. Okay, so you can see here x or y. It's the same if I say y or x. It's gonna give you the same value. The order doesn't matter. Okay, here. Is that okay? Here, also, this one is associative or associative. Okay, associative. So here in this associative, this is again similar to normal algebra. If you have 3 plus 2 plus 7. So I can tell you, you can calculate these two together and then you add 7. Or you can calculate these two together and then you can add 3. This is normal algebra. We have the same thing here. So you can see here, if I want to do x or y or z, okay, or z. So if I want to do something like that, so you can do this one first and then you can add z, or you can do this one here and then you can do or with z, with x. You understand what I'm saying? Yeah, I think yeah, for example, here, if I have something like that, ABC, so this output here is, no, let's I didn't talk about this one yet. So let's talk about this one. ABC, so the output here, A or B or C. Is that okay? It's the same if I take A or B this way, and then A or B or C. I add this one here. Not add, I do or with this one. Any questions? Okay. I'm gonna tell you something very important, very interesting. We call it duality. What is the meaning of duality? Look how if you have an expression like this one, okay, and this expression is true, okay, so if I have an expression like this one and I am sure this one is true, I can calculate the dual of this one, and also it will be true. So if you have a correct expression, the dual also will be true. So this one is the dual of this one, or the opposite, or this one is the dual of this one. Okay. So what do you mean by dual? I'm gonna tell you. So dual here means very simple. If you have an expression like this one here, if you convert, if you switch every AND with OR and every OR with AND and every ones with zeros, you will get a new expression. Again, if you have AND, make it OR. If you have OR, make it AND. If you have 1, make it 0. If you have 0, make it 1. So if I apply this one for any expression, I'm gonna get a second expression that's also true. Why this is interesting? This is interesting because you need only to memorize half of the theorems, because you can derive the other half by the dual. So let's apply what I'm saying here. But before I continue, I'm telling here variables and their complements don't change. So don't change the variable, or all what you have to do, any AND, you have to switch it to OR, any OR, switch it to AND, 1 becomes 0, 0 becomes 1. If you do that, you are going to get another expression also true. Okay? So let's start here. For example, you have X or Y. So I have here OR. All what I can do, this OR I can make it AND, as you see. Same thing here, OR becomes AND. So now if I know one expression, I can get the second one. Or if I know this one, I can get the second one. If this one is true, the second one is true. Okay. So this is true for any function, for any expression you have, or for any law you have, it's true. Okay. So same thing here. If this one is true, so all what I can do, I can calculate the dual. Okay. So here, this is or becomes AND, or becomes AND, so it becomes true. Okay. So if you have ABC AND together, A and B and C, this way, it's the same. If I do AND for A and B, and then the result here, AB, I do AND with C. Okay. Any question? You understand what by duality? So again, dual means if you have expression that's true, you can calculate another one that's also true. Okay. How can you do that? Any AND, make it OR. Any OR, make it A. Any 1, make it 0. Any 0, make it 1. Don't change the variable. It's the same variable. Don't change complement. Complement is going to stay the same. Okay. If you have one expression, you can calculate the other one. Okay. If the first one is true, the second one also is true. Okay. Now, for example, I want to prove the associative law. I told you an associative law, as I told you, if you have X and Y and Z. So I told you the way I can do it, I can take these two together. It's the same if I take these two together first, so I calculate this one first, and then again, This is not something new. It's the same thing. We do the same thing in normal algebra, in multiplication. 3 times 2 times 7. It's the same if you multiply these two first and then you multiply the next one. Okay, it's exactly the same thing. But here this is not multiplication. It's and. Okay. Anyway, so can you prove to me this is correct? You're just using truth table. Yes, I'm gonna do right now. So I'm using truth table. I'm gonna prove if this expression is true or not. So all what I'm gonna do is I'm gonna calculate this one as you see here. And then I can calculate this one as you see here, and then I'm gonna see if they are equal or not. Okay, so let's start first here. How many? I'm gonna keep repeating. How many variables I have? I have 3 variables. How many combination you have? 2 to the power of 3. Is that okay? 8. Okay. How can you generate these both all different values? Don't memorize them. Just there is a pattern: 0 1 0 1. 2 zeros, 2 ones, 2 zeros, 2 ones, 4 zeros, 4 ones. Okay, so now I generated all the inputs, all possible values. Is that okay? Now, after that, let me hide this one for now. Okay. Oh, okay, let me. Okay. Okay. Now, look here, guys. Now, I want to calculate this value and I want to calculate this value. And then I want to compare between them to see if they are equal or not, to prove the associative law. Okay. So how I can calculate these values? How I can calculate the first one? Okay, you have to do this end first, and then the result do it end with z. How I can calculate this one? I have to do this end first, and then the result I'm gonna end with x. Is that okay? So in order to do that, so I need to have a column here that has xy, because I need this xy here. Okay. Same thing, I need here yz here. So I'm gonna make xy here, yz here. Xy is just 1 bit, 0 or 1. Okay. Again, so let's do it. How can you have x here? So I'm gonna focus on x and y. This is y and x. How I can calculate this one quickly? How can you do that? Very simple. Look, it's not magic. You are doing and. You have here 4 zeros. I'm very happy that I have 4 zeros. So I'm gonna have 4 zeros here. I don't need even to look at the y. I don't even look y. I have 4 zeros. I'm gonna get 4 zeros because this is and. Then this is ones. This is 1 here. Okay. As I told you, if it is 1, so the output will be similar to y. Okay. So here, if you have 2 zeros, I'm gonna get 2 zeros. Okay. You have 2 ones, I'm gonna get 2 ones. So again, these four zeros are gonna make 4 zeros here. These 4 ones are gonna copy y to here. Anyway, so just quick way to calculate it. So now I calculated xy. Same thing, I wanna calculate yz. It's the same thing. Look here, 2 zeros. Don't think about it. 2 zeros here. Okay, 2 zeros here. Don't think about it. 2 zeros. Is that okay? Now you have 2 ones here. We have 2 ones. So it has to be similar to this one here. Okay. Or again, if you have just one input is 0, you're gonna get 0. Okay. Same thing here. Okay. Anyway, now I calculated. Now I wanna calculate these 2. So all what I'm gonna do here, this is 1. I'm gonna do and between z here, z and this one, right? As you see here. Okay, z and this one. Again, let's do it. Here we have 9 or I don't know how many. No, it's not. How we have 6 zeros here. So this, because you have 6 zeros here, I'm gonna have 6 zeros here, and then here. Look at this one. We have here 1 1 and 0 1. So I'm gonna have 0 1. Okay, guys. I'm gonna do the same thing for the other one here. So for the other one here, I'm gonna do x and between x and yz. Is that okay? Bit by bit and this is the result I got. Is that okay? Very important thing I'm gonna say right now. If you have a function or you have expression, how I can say these 2 expressions are equal? How I can know they are equal, right? Very simple. One way to know, we don't call it equal, we call it equivalent. So these are equivalent, okay, or equal. Okay, so if if the two functions or the two expression give you exactly the same output here for the input, okay, so they are equal. That clear? Look here. So here that means 0. Here I got also 0. 0, 0, 0, 0. If only there is one change, they are not equal, right? So I can have two expressions or two functions. I'm going to say these two functions are equivalent or equal if they give exactly the same result for all inputs, okay? That's why, because this column is identical to this column. Again, if there is only one bit change, they are not the same, right? So here you can think about it. For the same input, the two functions are going to generate the same output, so they are equal. Any questions? This is how I can know if it's equal or not. This is one way to know if the two expressions are equal or not. Here, they are. So that means I was able to prove the associative law. Okay. The second one here, I want to explain the distribution, as I told you before. Okay. So here, as I told you before, in the normal algebra, like if you have 3x plus 2, for example, so you are going to do distribution. Same thing we have here, okay? We have something like that. So here, A, and B or C. But this one should be similar to, you can do distribution. So this A, and, because this is and, it's going to go and here. This operation and, so it's going to be and or and, as you see here. So this is actually, it's going to become A and B, or A and C, as you see this way. Any questions? Distribution. Okay. Also, sometimes I need to do the opposite of the distribution. You need to know the two ways. Sometimes I have this one and I want to get this one. So I'm going to use distribution. Sometimes I have this one and for some reason you will understand later. If you have this one, I want to get this one. So also you should understand. If you have a common factor, you can get it out. Similar to what we do in normal algebra. So if you have 3x plus 3 times 2, for example, okay, here the 3 is common. I can take it here, it's the same thing here. Because the A is common, I can take A outside, so it becomes B plus A, okay? Any question here? This is similar to the normal algebra, okay? Let's look at the next one. And this is not valid in Boolean algebra. And I'm 100% sure you will forget it, because even myself, sometimes I forget this one, because this is not, we don't have this one in normal algebra. So let's see. First of all, how can you get this one? I'm going to use the dual, as I told you. How you did the dual, I'm going to tell you. Here it's and, so and becomes or, as you see here. Here is or, so or becomes and, as you see here. Okay. Same thing here. And becomes or becomes and. Okay. And becomes or. Okay. So I just got the dual, and I told you before, I don't even need to prove this one, because once this is true, for sure the dual is true. Okay. But let's just understand it first. Once one expression is true, the dual is going to be true for sure. So, but let's understand, because this is very tricky. I told you, 100% you will forget it, because again, this is not something you are familiar with it in normal algebra. So you will forget it. Look how it works, guys. Actually, similar to what I did here, I'm going to do it here. Very simple. Okay. So what I did here, I did distribution, because there is operation here dot. There is and operation here. I just did a distribution. I'm going to do the same thing here. Okay. Because this is the operator is or, and we have and here. So I'm going to do distribution here and here. So actually it becomes A or B. Okay. So here, this is a term. I'm going to repeat it, because okay, here. And this is and. This and is here. Okay. So here what I'm going to do, A or B, A or C, and the relation between them is N. Okay. Also, you should look at the other side as well, because when we use these theorems or these expressions, sometimes you have this one and you want to move to here. Sometimes you want to do the opposite, so you need to pay attention. So the opposite here, you can see A plus is common. Look here, A plus is common, so I can take it outside. It's common. Any questions? Again, I didn't prove it, but I'm telling you, if you want to prove it, you can simply make a truth table. So if you want to prove, this one is true or not, you can make a truth table. You have ABC, so you can make one column here for this one and another column for this one, and then look at what values you are going to get here. If they are exactly identical, that means they are equal. Okay. Actually, I did it anyway. So I did it here, as you see here, but I'm not going to spend time teaching it. So you have here all of them ABC. So I calculated this one here. I calculated this one here. And then when I look at this column and this column, they are identical. Look at bit by bit. They are every bit is similar to the other bit. So they are identical. That means this is true. Okay. Same thing for the other one here. It's exactly, this is the dual. Same thing. I made this column. And I found they are identical. Okay. So one way, if you have two expressions, and I want to make sure they are equal or not, one way to do what I did. Okay. Any questions? We still have 3 minutes. Any questions? De Morgan. Let's see what De Morgan. De Morgan, I think this is the name of the guy who found this one. Okay. So let's see how it works. So De Morgan told us, as you see here, if you have X or Y, okay, and everything is inverted. By the way, don't be confused. Sometimes we do this way or sometimes we do this way. It's the same. Okay. Sometimes we put bar over bar this way, or sometimes we put prime. It's the same. Okay. So what this means? It means you need to calculate X or Y first, and then you complement the bit. Because X is a bit, Y is a bit, and after you do this operation, the result is bit. You complement the bit. Is that okay? So here, Morgan told us if you have something like that, this should equal to, you need to complement the first one. So it should be X prime. And you need to complement the second one. And any OR, you have to make it AND. Any AND, make it OR. Again, what De Morgan told us, okay, if you have something like that, okay, any AND, make it OR. Any OR, make it AND. And you have to complement the value. That's why if you have X or Y complemented, it should be equal to. Complement the first one, complement the second one, and this one should be AND. I have the dual of this one should look, it's the same thing. This is what we call De Morgan. So if you have X and Y prime, okay, this is equal to, okay, complement the first one, complement the second one, and then you have to make it OR. Again, in order to prove it, I created truth table here. In the truth table, as you see, I made a table for this one, I made a table for this one, I made a table for this one, I made a table for this one. And I found these two are equivalent, these two are equivalent, okay? But how? Because look here, what I did, I have X and Y, okay? So here, this one here, how you calculate this system here? Very simple, you have to do OR, X or Y, and then complement. So I first here, I did OR. I have X and Y, I did here X or Y, and then I complement this one. When I complement, you have to complement every bit. That's what I'm saying. So I have here X or Y complement. So you see here every bit is complement. So if you do this way, I find they are equivalent. Okay. The last thing, just 1 minute, just less than 1 minute, just to finish it, just this slide. The last thing here, guys, I want to tell you something very important. I know it's a little bit confusing, but I want to clarify to you. Look here, guys. For example, here I explain, I told you X plus Y complement. In reality, this X can be something like AB, and Y can be something like C prime D. Okay? Still, you can apply the same theorem. Okay? So you can consider this is X. You can consider this is Y. So I take the first one, I consider it X. So I complement it, I take the second one, I complement it. So when I say X and Y, so actually it can be something, any expression. I can name this expression X, I name this expression Y. Same thing for the rules I explained before. So for example, I told you A and 0 is 0. What about A and B and C and 0? I can consider all of this equal to x. So it's going to be x and 0 is 0. So everything I explained before, any variable can only be one variable, or it can be something logic and or something, because at the end it's going to give you 0 or 1 as well. Okay. Anyway, that's enough for today.